All right. Good morning, good afternoon, good evening. As I said earlier, from wherever you join us, welcome to this month's Oracle DBA Masterclass series. It's a pleasure to announce today's session, which is one of my favorite topics, RAC, Real Application Clusters. And looking at the numbers of participants we have today, I think you feel similar. It's also a pleasure to have Anil with us today as the expert on the topic, who's going to present later everything about RAC and more. Before we kick it off, let me, as always, quickly introduce the team aboard. So Anil, as mentioned before, will be the hero of the day, going through the content, giving you all the details about RAC. And then we have Jesus, Stefan, Rob on the Q&A panel, together with Osama and myself, helping you with any questions about the topic, questions about next sessions, questions about the whole program, anything you want to know. Use the Q&A button here in the Zoom session, and we'll be happy to help you out. All right, without further ado now, I want to hand it over to Anil, and it's a pleasure to have him here because actually it's quite early for him, just about 8 a.m. So I'm really thankful, grateful for Anil to be here because he's really the expert. Anil, please, you take on.
Great. Thank you. Thank you so much, Kevin. So if you could please stop sharing, I can start. There we go. All right. Just a second as I present. There you go. All right. So everybody can see my screen, I guess. There you go. Moving around some of the pesky tabs around, and I should be good. All right. So welcome to my session on Oracle Real Application Clusters. This is specifically covering the administration and performance tuning masterclass series. As Kevin said, I'm Anil Nair. I'm the product manager for RAC and ASM. I have turned on the video just for the introduction. I just want to make sure that there is no hiccups. So I will turn off the video in a couple of seconds. But just wanted to say, welcome everybody. Thank you so much for joining this session. All right, having said that, let's get into some of the other details, like my Twitter handle. I would really encourage people to go there and send me if you have experienced some good or bad issue. Also, I have a lot of my what I call as previously written blogs and other things in LinkedIn and my earlier deck in the slide share. All right, so what are we going to cover today? We're going to cover all of these, and this is what is the agenda that we had actually advertised when we were talking about this masterclass. We will cover a lot of this, and it's going to be really challenging because I have like about 45-ish minutes. But as I said, if you have any questions or have any doubts, or even if you want to suggest future sessions, you can always send me the tweet and I will make sure I can accommodate you. Okay, good. So what is the one thing different? I saw the first question that came in from someone was, hey, I'm using VMware. What's the benefit of RAC? Well, right there in the first slide, and I tell you, this was not pre-staged, but this is the first slide. And this basically shows that Oracle RAC is perhaps the only, well, there's one exception, which we cannot talk about. It's perhaps the only database solution that provides you available and active instances that can scale, read, write, and hybrid workload. The other one is the IBM mainframe. We don't want to talk about it at this time, but this is one of those only solutions. The benefit is that as long as your application is supports like Oracle single instance database, it can work on Oracle RAC, simple. And we have been known to scale what we call as OLTP transactions on the left-hand side, and then the analytical transactions, you can do it either way. You can have 3 nodes supporting OLTP and all that. So how can I say that? Well, long time ago, and I'm really telling long time ago, like 10 years ago, SAP folks ran a benchmark on some of their SAP workloads, and they could actually see that just by adding nodes, we could be able to scale. Now, this is something I've been using for a while. What is also important is that nowadays we have this new application paradigms, like people use, hey, I want to use IoT. Well, great. Guess what? RAC also scale IoT workloads. So if you see in this graph that I'm shown, we're able to insert millions of rows per second on a full rack. Now, what are these numbers show on the different, 1, 2, 3, 4, 5? Well, that shows the amount of, the number of IoT records that can be inserted in one shot. So if you use arrays, the bigger the array, the better the insert rates, which is perfect for IoT workloads. So if you see this number, this is about 200 million in number 2. Guess what it is? It's the number of rack instances. So if you use an array of 100, you get certain. And if you use an array of 5,000, you get even better. And remember that this is also active-active. Now, similarly, we also scale like the new queue-based workload. So if you're looking at something like a Kafka queue-based workload, we are able to even do better with the different permutation and combinations of as shown on the right-hand side. Similarly, with JSON, we are able to do, if you have a JSON type workload, we are able to scale JSON types workload. So in short, we can scale all kinds of workloads. And how can I claim that? Well, if you have ever deployed anything on the autonomous database, what is an autonomous database? It's nothing but Oracle real application clusters running on Exadata system with all the automation and the data center optimizations of the Oracle Cloud. And we have so many customers putting or deploying different types of application. Now, remember, what we have done is also we provide you various options. We give you a dedicated option, or we can do shared. In shared, we make sure that it's not just your data that is shared, but also your performance that is shared the way you want it, without even you knowing about who else is running on the same cluster. This is really, really important to understand. Why is this important to understand? Because if you are an on-premises DBA, you can pretty much take away from this is, hey, if I architect it correctly in my on-premises, I could actually benefit from all of these features myself. Obviously, not every single feature, but some of these features, like making sure that you're able to share between the different workloads. So if you have looked at the autonomous database and you know that we allow you to scale, so if you click on the scaling link, you basically are able to scale by just clicking some button to make your OCPU count go higher. And guess what happens behind the scenes? There are more rack instances being added. Okay, so that's how you can scale up and down in using Oracle RAC. Now, what provides this scalability? Well, there is a whole laundry list of items I've provided there, which says these are the RAC scalability features. The important thing to understand is between 11G and 19C, we have made this about 5x faster as we have implemented some optimizations. Similarly, for availability, we have made it 4x times faster between 11G and 12G, and about 1 times faster in 18C. So overall, you can say we're 6 times faster. Now, I can claim all that, but I have to back up my claim. So I will get into some of the features that explain why we are able to do this. Okay. With 19C, what has happened is we have been able to go back to our customers who have looked at Oracle RAC, let's say in 10G timeframe or even 9I timeframe, and they said, oh, this is too complicated. We are able to go back to them and say, hey, look at this new Oracle RAC, which we call it as a new generation Oracle RAC. And our idea or our premises for this new generation Oracle RAC is we will provide you scalability in HA without any changes to your application code. So that's our we're trying to achieve, that is, hey, we will always try to give you the best scalability and availability, and you don't have to change anything. And there is no interruptions to minimum interruptions, and we provide you on a wide variety of platforms. On premises, on AIX, on Solaris, on Linux, and on Linux itself, we have like Red Hat Linux, and we have Oracle Linux, and also we have this in the Oracle Cloud. So what I'm going to do is break up this into 3 areas. So we talk about the scalability and availability section, and then we'll talk about the application failover and application session management, and we talk about the overall lifecycle management that you have to go through. So let's look at the scalability. Now, remember, when you use RAC, you don't have to change anything to your system in the sense of how you manage it. You basically have these 4 nodes, and they have the same SGA type, like if you have buffer cache, shared memory, and everything. We have this algorithms behind the scene which will automatically work for you. So what are some of that components? Now, the buffer cache is something that forms the major part of the SGA on any kind of workloads. What we want to make sure is that regardless of where you connect, like in this case, this session is connecting to, say, node number 4, we want to make sure that regardless of you connecting to 4 or 3 or 2, even if your block is somewhere else, like in this case, there's a concept of a block monitor, which is telling you that, hey, this query, the block monitor is on node 1, and then node 2 has this block with old SCN. Doesn't matter. This is the most complicated case, but we will handle it for you. We will make sure that the query gets the block for the SCN that it wants. So we always give you consistent responses back. And even though this is a three-way communication, which is we call the worst case scenario, for which we have optimizations to prevent and change, this is something that the user does not even have to worry about. Okay, we have this resource monitor capability. The resource monitor is basically something which will automatically move what I call as the monitorship to the instance where the buffer itself is. So we do this with optimizations during startup, and if that is happening during runtime, then we change it during using this dynamic resource monitoring feature. So let's look at some of these sessions, and there are some interesting questions, and I'll try to answer them. If I get to the end of it, those my colleagues are already on top of it. Looking at some of the features. Now, what I've done is taken some of these features and broken down into scalability and availability. So let's look at the scalability ones first. Now, over the years, and I've broken this down into the different versions. So if you look at it, I have a 12C version, fixes that went in, 18C fixes and 19C, and then I call it future. Some of them are in 21, some of them are in the upcoming release. Okay. What we have to understand is that we are doing optimization all over the place. Now, the ones that are covered in the red, I call it the ones that are specific for Exadata. And although I put the fast index split in the Exadata one, there is some benefits to even generic ones. Okay, so if you want to know what are the benefits of running Oracle Real Application Clusters on Exadata, a lot more performance and other details, and there is this white paper that I put a link for. And we can, it covers this in whole lot detail. What is important though is we have been using what we call as this execution as one of those really cool pieces of technology. What execution is remember in RAC, when we need to send and receive messages, they are basically going from the user space to what we call as kernel space. There's context switches that has to happen. With Exadata, what we have done is we have introduced mechanisms by which we can directly read the memory from the other node, which we call it execution. And we can do this in user mode, which means we don't have to do context switches, which makes it latency gets even far more improved. And we'll look at some of the performance numbers at the end of the session. Okay, and I'm not going to go through some of them, but the most important one is this indexed contention optimization that I will cover in detail. But basically, overall, we have been able to add more and more features that makes it easier for you. And by the way, none of these features, well, except one feature is called scalable sequences, which we will talk in detail. These are all automatically available to you. So if you go to 19C, and if you're using Exadata, you get from all of this. If you're using generic systems, you get from a subset of some of these features, the benefits you can take without even changing your code. Okay, so as I said, the ones that are highlighted are the ones that we're going to a little bit cover in the future. Okay, one of the really good piece of optimization that we have is what we call as the in-memory commit cache. Now, what is an in-memory commit cache? Very simple is when you're inserting, updating, deleting from multiple nodes, what happens is internally the nodes need to sync up, the instances need to sync up and say, hey, did that transaction which used that, did it ever commit or is it still going on? This information is usually looked at by looking at the undo header. Now, usually this would happen as we would send and receive these messages. Now, what we are doing is we are using what we call as the in-memory commit cache, so that the LMS will respond with a batch message. It contains all the states of all the requested transaction IDs. So we eliminate the need for repeated round trips. We reduce the load on LMS. So initially, if you see before this feature, which means if you run a workload in a say pre-19C environment, you would see this GCCR two-way waits, and now you would be seeing more of GC transaction table wait. But remember, our messaging is reduced. So it's not just the wait event we have changed, we also optimized it so that the wait event is just waited upon for a very lesser amount of time. Similarly, what we have done is we have optimized this in the way we do what we call as downtime. So if there is any downtime planned or a planned outage, what is a planned outage? Well, today, you know this, if there is a security fix that you need to apply on the operating system, or sometime you have to replace a physical hardware like a memory card or something, you have this need to take down the instance. Now, obviously with RAC, you don't need to, you could take a benefit of what we call as the zero downtime optimization. So if you say, hey, servctl relocate service, we will relocate the service. That means that that instance is not having any current services running, which means also the user sessions are out. On top of it, what we do is we will make sure that remember we talked about the resource monitors, we will distribute them over to the other instances so that when the node or the instance is taken down, there is no checks for any recovery or anything, because we have already moved them out, which means they go down quickly and they come up quickly when you restart it. And also because you have relocated the services, pretty much the application sessions are unaware that instance one is going to go down or node one is going to go down. So this is something really cool that we have done to reduce what we call as the planned outages, which is what we call as providing you continuous application availability. Okay. So in this case, you have taken node 3 as an example, and if you saw the animation, we moved all the monitors to the other instances, so therefore we can continue. I said earlier that I will talk a bit about what we call as the right growing indexes. The right growing index is a typical workload where you start with a table which has an monotonously increasing number. For example, in this case, to make it very simple, I have 1, 2, 3, 4, 5, 6, 7. So you can think about it as, say, you have a startup and you have an employee ID 1, 2, 3, 4. So you have, say, 7 records with employee ID 1 to 7. Okay, this is perfect. You're growing and this is good. Now, what happens before I get into the detail is that this is not really a RAC issue. What I mean by that is, think about it. What would happen is, let's say these are the 7 maximum records that can stay in an Oracle 8K block. If you want to add the eighth record, what would happen is the block will be split into 1, 2, 3, 4, and 5, 6, 7. Okay, we kind of split it in the middle. Obviously, so we do it this way. Now, as you add more records, you're a startup, you're growing very good. So you have added more records. So 5, 6, 7, and then 8, 9, 10. Great. Now what happens is, if you need another split, then we keep going on splitting this. But if you see on the left-hand side, the blocks are not completely full. So what happens is, if you need to go and reach a block, let's say if you want to find out about block number or row number 10, then you need to go from the first block to the second block to the third block in order to get to that block and understand where that record pointer is. Now, with all that, you can see that if you run a workload in 11G and previous releases, you are not actually able to scale. But with 12.2, and I would always say 19, we are able to at least scale, and we can get you consistent executions with all this, index split issues. So what have we done? What we have done is we have reduced with our leaf block splits. We have reduced our messaging, and we have also provided, especially for Exadata, we have, because of the features like commit cache, the undo block RDMA read. Now remember, what is undo block RDMA read is basically reading the undo block using RDMA, or as I call it, just able to query from the remote side the undo block. We also have Smart Fusion block transfer that helps with these kind of workloads. Now, I have one item I identified here, which is basically called scalable sequences, and I have a bit of a way to highlight for you that this is something that this is perhaps the only thing that you have to consider as a DBA that you have to do or manually do it. The rest automatically you benefit from without any changes. So coming back to RGI. So how do you know? Hey, Anil, I don't even know how to figure out if I'm running into RGI issues. Well, this is a way by which you can see it. Essentially, you can see that there is a TX index contention and there is a GS resource hash split. So you can see that basically 21 plus 1, about 22%. We are waiting on global NQ handling. And then you can see that the GC buffer acquire and release is about 50%. So this is an idea that you can look at maybe. And obviously, the specific numbers depend on your particular workload. But this is a good way to know that, hey, if you see a lot of NQ for TX index contention, this is some workload that can benefit from it. So as I said, what are the optimizations? So we kind of have all of these optimizations. So we try to keep the branch block at the splitter. So basically make sure that when the split can complete as quickly as possible before we let the block being pinged away. We also have scalable sequences. Again, I'll talk about in detail in the next slide. You could leverage what we call as RAC sharding. Again, if you don't know what RAC sharding is and want to know more about it, please let me know. You can DM me or put it in the Q&A box or whatever. We also have this delayed ping, basically, which allows the local sessions to make more changes to a block while the redo to that is still pending. So if there's a change, we have a block split and there is a request from the remote node, but there's another block split request and on the same node, and our redo is not yet completed, then we can do one more block split because that's not going to add too much work. So that's some of the optimizations we have. So all of this help it. And the most important one, which is what we call as a fast index split, which allows for the block, the leaf block split completion to be in the buffer cache instead of going through this global MQs. So we even try to optimize this in the buffer cache itself. So as you can see, we've done a lot of work to make sure that right-growing workloads can be optimized and can scale as fast as possible. In fact, some of these changes have helped improve some of the typical wait events on an internal benchmark. We could see about 50% better performance at this. Okay. Sequence. Now remember, sequences and indexes are somehow related. Earlier part I said about employee ID. If you are a modern application development or developer, you are hopefully using sequences and not using the older methodologies to increment a certain number. Sequences are perfect for that. Now, sequences also are something that cause index loss contention during heavy OLTP. So, again, this is not a RAC issue, but it gets amplified, and the issue can be mitigated by using what we call as scalable sequences. As I explained, how do you know if it's a sequence issue or index issue? You look at the NQTX contention, you would see it. So, as I said, this is the only one that you need to worry about when using scalable sequences. When you manually try to do, this is the only one that you have to do manual changes for. So you have sequences. All sequences that you create can be altered to what we call as scalable sequences. So essentially what we do is you can say alter sequence name, and then you can say scale, and that's the only thing that you need to know. But what changes in the middle is that if you use sequences, let's say you have 4 nodes, then the number is not going to be incremental. So what I mean by that is if you are saying running an OLTP transaction on all the 4 nodes, and if your application has a need that every number should be one after the other, and it should not be having any what we call as gaps, then you may not be able to use it. But we work with so many customers. We looked at the hundreds of sequences, and we found out that about 75 to 80% can be converted to scalable sequences. And so that made it much more easier. Now, this is the only part where a DBA has to work with the application developer to understand the business needs before they can decide whether they can use scalable sequences. Okay. Quick time check. I'm good, I think, on that. Any question that I should really answer live, guys, let me know. Otherwise, I'm going to continue. One of the features that I'm really I've talked about it multiple times, but I cannot talk enough about it, is what we call as near zero downtime reconfiguration with Recovery Buddy. As in life, Oracle RAC, also uses what we call as the buddy mechanism. So essentially, what happens is in Oracle RAC cluster, the buddy tracks changes all the block changes to the instance. So every instance has a buddy that is designated to that instance. And this helps us to quickly identify blocks that require recovery during a reconfiguration. So with this feature, we are able to do like about 6 times faster than compared to the what we call as previous releases. And with 19C, we also have this optimization where we fast track non-mastered resources so that we can go even faster. So what is that? How do we do this? So remember that when you have a reconfiguration is essentially when an instance can join or leave the cluster regardless of planned or unplanned downtime. So what happens is in Oracle, we have a process called, the cluster-wide process called CSSD that can detect these things. And once the CSSD detects it, the Elmon process of RAC will talk to the CSS and say, oh, there's a new instance, or there's an instance that has been evicted. Once it happens, we have to elect a recovery master, or recovery monitor, and the recovery monitor will use one of the SMONs to get a lock, which means there's an election going on, and then we will do the read and apply and all that. This is what used to happen earlier. What we have optimized is with Recovery Buddy, we have basically taken down so many phases so that we automatically have the buddy for that instance to be elected, the person, the monitor who can actually make that change. And then we apply the redo. So redo read is optimized via memory reads because it's all we don't have to go to the disk to read it, and apply recovery is even optimized because we don't need to switch between reads and writes. So we can able to push all the writes in as quickly as we can, and as long as you have a very high performant IO system, it can even go better. So this is something that really helps reduce the time that is taken during what we call as reconfiguration. A lot of details there, but basically the highlight is, as I said, if you look at these 4 instances, you have an instance dedicated to be a recovery buddy, and usually we try to make sure it's not it's on a separate node. So if you see instance 1's recovery buddy is on instance 4, recovery buddy on 4 is recovery buddy is running on instance 3 is taking care of instance 4. So we do this. And then the process that is really involved is what we call as the RMS process. And the RMS process has a small area dedicated to it where we can track all the redo log changes so that we don't have to go and read to the disk. All right. Now that we have reached what we call as taken care of all the RAC or what we call as server-side optimizations, it is important to understand that, hey, what's the point of your server is up, but your sessions are still waiting and not doing anything because your server is actually up, but the sessions are waiting on other things. So let's understand what we call as improved session management session. So session connection basics are not changed for a while. Basically, sessions connect to the database and they expect some answer and the database take care of it. What happens with RAC is we have what we call as scan. So you have a single client access network that is this entity that everybody connects to. When you connect, you have a choice. You can say, hey, I want to do direct connection or I want to use a connection pool. We highly recommend using a connection pool. And the connection pool will make sure that, if you have hundreds and thousands of transactions, the connection pool will help you reduce the load on your database side. Again, you're welcome to use direct connection and we'll happily manage that load, but there are benefits of using connection pool. Now, even though you use connection pool, if you see, we are able to route your session to different instances. So in this case, we have this idea of either being able to failover, load balance, and we provide what we call as all these features so that when a connection comes in, we can send it to node 1 or instance 1 or instance 2 or instance 3. You don't have to worry. Basically, from your side, you don't have to change anything. We also have ideas. Let's say in this case, if node number 3 is extremely busy, then we send a mechanism, what we call as a notification to the connection pool or directly to the session if there is no connection pool. So this is something cool so that the session does not need to worry, hey, am I going to be connected or rerouted to this very busy instance? I really cannot afford that. Well, don't worry, we took care of you. Okay. So let's understand how this failure handling works. So when a connection session, like there's a new connect request, we go to the connection pool, or if it's a direct one, doesn't matter. We go to what we call as the scan. The scan listener will route to the DB listener. Let's say it goes to the first node. This is perfect. The first node says, all right, this is good. But as it is trying to respond to that, there is an instance or a network failure, a public network failure. Now, without waiting for TCP timeout, what would happen is there is something called the grid infrastructure, which will relocate what we call as the virtual IP to some other node. When this happens, we generate what we call as a gratuitous ARP. So automatically, there'll be an ARP table update event generated, which will tell the session that, hey, there is something wrong. Don't wait on this timeout. Just go and do something else. Now, in this case, what it's going to do is it's going to say, hey, I'm going to let my connection pool know that something else happened at that time, and while I'm going to be reconnected to my other third node. So it retries the connection, goes to the third node. There's an ONS notification sent about the thing, about the node instance 1 or node 1 being down or public network being down, and everybody's happy. So this is something that is really, really happening below this covers. You don't even need to know. Okay. And I'll show you an example on how this can be tested on your system. Okay. So how do you get benefit of all that? As I said, there's no change to your code. You basically make sure you use a recommended connect string. In our recommended connect string, what you have is you have basically make sure that you're using a service name, and then you want to make sure that you're using what we call as, in this case, I have a primary scan, which is my primary database, and the secondary scan, which is my standby database. Now you may say, Anil, I don't have a standby database, in which case you can take this out. But you need to make sure that your service name is what you always use the service name. We have these two specific parameters, that is basically the transport connect timeout and the connect timeout. And what they translate to, as I've basically put out there. But we will test this out so that we can see how this is beneficial for your failure timeouts. So let's say, what I've done here is I basically said, hey, I'm going to use TNS ping on my internal setup. If I try to simulate a network failure, I get basically what we call as about a minute, which is basically what my TCP timeout is on my operating system. And when I set the parameters, as I said in my TNS names.ora, immediately I can see the benefit. It's almost no delay. So it goes quickly. We find out quickly. We relocate quickly. This means it's your application does not need to continuously wait, and your application users do not need to worry about waiting for a connection timeout. Now, remember, as I tell everybody, these are good numbers to start with. You can say, hey, I want to increase this to say not 3 retry delays, not 3, or connect timeout is not 3. I want to make it 1. That's fine. You have a perfect network. It all depends, but these are good starting numbers from which you can start with. Okay. The other part is, remember, as I said, if you have a workload, like in this case, you're running 3 different services on your Oracle RAC clusters. You're running orders, you're running payrolls, and you're running sales. Now, when you have your workload coming in, and if you have a certain module, let's say that all this information or what certain part of this sales during certain point of time is coming from EMEA, or is it coming from APAC? You can make sure that you can, what we call as tag your work coming in. So it goes to particular instances. In this case, you can add to your connect string something called co-location tag. So if you say co-location tag is order, co-location tag is sales, co-location tag is sales _ EMEA, what would happen is all this workload will be routed. So even though we have choice of sending it to 1 and 2, and assuming that the load on 1 and 2, or in this case, instance 3 and 4 is same, then using the co-location tag, we will try to send all the work to either 3 or 4. Now, as I said, this makes sure that you're internally, this makes sure that there is no need to send and request blocks from the different instance. And this also helps with scalability. So again, just by changing or adapting to the TNS names, you can be, or you can planning with your TNS names, the correct TNS names, you can benefit from all this scalability and availability, options that we have. Okay. I'm not going to talk much about application continuity because the next session in this series of the master class, you're going to have a whole 1 hour dedicated to it. But essentially, what I'm trying to tell you is that enabling via servctl application continuity attributes in your service, you can benefit from all of this without changing your application. Okay. So now that I have reached what I call as I've taken care of the showing the features that help the server. I've taken care of all the session specific benefits. But one thing that I've not covered enough, that I've not done much in the past, is talking about efficiently managing multiple Oracle Real Application Cluster deployments. Hey, so what I call as lifecycle management for my database. Now you have deployed your Oracle RAC, make sure that your TNS names and services are set up in your application side. But the biggest thing I hear from customers is, Anil, I have like hundreds of deployments. I really need you to tell me how I can manage this efficiently. Oops, sorry. So I have broken this down into 4 areas. I call it as the install, the patching, the management, and tuning. Now, these are things that typically DBAs do all over what we call as the life cycle of the system. Now, installation, I'm hoping nobody today does like the GUI and then clicks next and tries to enter. Hopefully today you can use what we call as the automations that we have provide, so that you can do one command install and one command this thing. You can use your own tool, or we have made it easier for you to benefit from it. So in this context, I'll talk a bit about the installer optimizations. We'll talk about patching. We talk about storage management, and we talk about the AWR, or the way to tune and understand how these things are reflected in a report. Okay, so let's talk about install. Between 12.1 and 12.2, we have changed from an install-based system to what we call as a gold image-based deployment. So instead of doing all these things on the left-hand side, automatically all you do now is you unzip the image homes to Oracle Home, and then you run grid setup. So there is no need to do temp location and this and that. We automatically are able to do a lot of these things. What we are also able to do with this gold image based is that you can now say, hey, my XYZ company has a particular gold image, which means I have 19.11 or 19.14 with these 3 patches that are very specific to my environment, and you can use that to just deploy on any other server. So no need to go to 19.3 and applying it manually. Nope, you can automatically do it because of the gold image-based system. One tool, basically, or one grid setup command to do install, configure, upgrade, add node, delete node. This makes it so much easier for deploying what we call as if you are using a DevOps mentality to deploy databases, you can automatically run the grid setup with a pre-created configuration file and do grid setup, blah, boom, you got everything deployed. Okay. We also make it easier that when things go bad, like for example, in this case, we all know that clusterware has a lot of processors and it takes care of a lot of resources in this case. But minor changes, and this happens to customers for whatever reason, we have seen that, hey, suddenly the stack won't start up. What we do is when the stack doesn't start up, we actually run some checks. So in this case, this is actually a real customer case where a customer by mistake changed the permission of certain binary. So now we actually tell them that, hey, look, you have a problem here. The owner of the file did not match what I expected. We expected it to be great, but you found it to be Oracle. In this case, the customer by mistake tried to run some command as Oracle user by giving some special permission. Regardless, the good thing is we're able to tell you this upfront. So this makes it so much easier. So you don't have to open an SR to find out. We tell you upfront. Okay. For patching, also we have done a lot of improvements. For example, we have this grid setup that you can switch home or switch grid home option for out of place patching. So in this case, as you can see, from 19.13 to 19.15, it's like switch. You just flip a switch, grid setup minus switch grid home, and we move it automatically to the other new home. Now remember, this is an optimization because you have done all the work of putting the 19.15 bits and copying and all that before your application even has to go down. It's still running on 19.13. But the moment you decide that, all right, I have got my approval from my management and my business leaders that, hey, I want to go to apply the 19.15 you basically go and click one switch, or which is grid setup switch grid home, and we'll move it to the 19.15. We also have what we call as merge the auto upgrade. So if you run auto upgrade, we'll tell you that auto upgrade checks, and we have merged it with the cluster verification checks. So these are all going to be in one place for you. Okay. Similarly, in management, remember there are two aspects of management. We have to manage the storage and manage the compute. So in compute, what we do is we have provided for you what we call as FPP. And if you're using Oracle RAC, or if you're already licensed for Oracle RAC, FPP is free. FPP is the new name for RHP, okay, rapid home provisioning. FPP actually does not only installation. Installation is very easy. Installation can be done. You have vagrant script. You can write your own script. That's not the hard part. The hard part is patching, and also the hard part is adding and deleting nodes. All of this can be done by FPP, and you can do what we call as gold image. You can have your own gold image. You can just, with one click, that finger is supposed to show you there, is that you basically click once, and automation will make sure that will save you countless of hours of performing this task. I keep saying this. I want to make sure I'm honest here. You can do a lot of these things with install. With patching is where it gets interesting, and FPP can make sure that it use features like, for example, zero downtime grid infrastructure patching that can reduce your downtime. And you don't need to do anything. FPP can read some metadata and know that, hey, this can work for me or in your environment, and do the right thing. Similarly, in this one, you say, hey, Anil, I have this RAC system running on my on-premises for a while. I'm going to Exadata on-premises. How can you help me? Well, we have a lot of these things that you can do. For example, if you're moving to the XaCS or XaCC services, you can use zero downtime migration to migrate from, say, on-premises to the Oracle Cloud environment. Similarly, we have zero downtime upgrade option, ZDM and ZDU. The URLs are there. If you click on them, you'll take you there. For storage, we have this new thing called ASM filter driver, which is a replacement for the ASM lib. So what does ASM filter driver provide? If you look in the stack, it somehow is between the operating system and ASM. So you have in the base, you have the storage hardware, you have the operating system, the filter driver, ASM, and database. So we have this running as a kernel driver, which is what ASM lib also was. The important part is the filter driver attempts to filter out any non-Oracle IO. So if you do like a DD to ASM device, which is not like if you do manually, we will try to silently ignore that IO. Remember, this is there to reduce the chances of customers overwriting their ASM devices, because this came up a lot with customers where they say, hey, my sysadmin did a DD to the header of the ASM. Now my ASM disk group cannot mount. Well, using ASM filter driver, we are able to prevent or reject IO from non-Oracle entities. This helps because you don't have any downtime related to, or you would prevent any downtime related to inadvertently rewriting, overwriting some of the headers. The other part is, everybody talks about, hey, I want to have multiple databases consolidated on a single database environment. I want to make sure I use a single storage. This is all good. But once you have, say, 5 databases, 10 databases on the same cluster, you have this issue where, hey, how do I make sure that one database does not take over all of the space? For example, here, if you have database 1, database 2, database 3, I have like this database 2 DBA pre-allocated some storage. Now, because of that, database 1 cannot have space. Well, how do you prevent that? Well, we have this thing we call as, you can set up quotas. So when you consolidate, you can set up quotas for some of these databases. So you could say quota at the PDB level or quota at the database level. So how do you do that? Well, if you manage your ASM disk groups with what we call as the flex disk group, which is the new type of disk group that we introduced in 12.2, and you can create what we call as quota group. So if you have 3 databases here, you can say, hey, there is a database 1 has some limit, maximum quota. So after it reaches the quota, if it tries to allocate more space, even though there is additional space in this storage layer, we will give that will, the process that is trying to allocate this space will receive an error. So this is something that allows you to easily plan your consolidation without having to, worry about how many, whether some other database will eat up all my storage. Okay, let's talk a bit about tuning. And every time I talk about tuning, by the way, I have a whole 60-minute session dedicated for tuning that I've talked about in the past. I've taken some snippets from there to talk about specifically here. As I said, our goal is to make sure that we do in the backend automatically things that will improve your performance. Database reliability framework is one such important project that we have introduced in 19C, which helps to improve your performance. So what we do is in the backend, remember that when we are when RAC is gets a whole big SGA, let's say it's managing a terabyte of SGA, it has a big chunk of memory that it pre-allocates for certain components. What we do internally is we look at the database memory management, including the SGA, including the process monitoring, including the process use, including the memory that is used by individual processes. We monitor all that. We monitor all that and make sure that the usage is within what we call as optimized. So let's say, for example, if there are certain internal structures that we need more memory from, and that memory is fragmented, then we know that automatically that, hey, maybe what we should do is that internal structure is growing in this type of workload. So maybe we should give it a bigger chunk at one shot so that it doesn't need to have these smaller chunks and need to traverse this chunk separately. Similarly, that helps with reducing what we call as CPU usage, because remember, the more chunks need to traverse, the more CPU usage. It also helps reduce brownout, because if you're going to time out trying to allocate some memory, we get some errors. We also try to dynamically adjust this, and all of this works very well behind the covers, especially in large SGAs. There used to be a MOS note, and there is still a MOS note about, hey, if you have a large SGA, say 1 terabyte and higher, then these are the things you need to do. Well, now we have taken a lot of the information of that note and made it behind the scenes automatically for you, so you don't need to do it manually. So how do you know this? Well, we run this into what we call as the LMHB process, which means it's a non-fatal and restartable framework, which means it will be running without interrupting your workload. We have all these metrics, and this is a small screenshot of what are the metrics. You can look at OS memory, OS load. We can look at CFIO weights, the control for IO weights. We then take action about things. So, for example, if there is a CPU load, the backgrounds are slowing, then we enable what we call as an internal resource manager plan that will try to reduce taking more and more CPU actions, which can cause increased CPU load and other issues. Okay. Now that you have everything is done, you're running your application on the RAC database, everything is good, and then you say, hey, I want to do this performance tuning. Well, sure, you can do performance tuning, but your 4 instances. Well, guess what? You don't need to worry about 4 instances to be tuned separately. You will have what we call as a global AWR. So you can have one report to tune multiple instances. So you can see here in this case, for example, instance one is clearly more busier than the rest. You can see that there is a lot of work on instance one. The other guys are not even doing any work. This just means that the system is not set up with services correctly to do the workload, or maybe it's just the way that you wanted it, which is fine, in which case it's fine. You also look at the different instances, the physical reads, the physical writes. You can see all of these changes and in just one report. Okay. We also provide you what we call as the systat and global messaging information for the 4 nodes. So in this case, you can see that each node, you can see the block received, the block served, the amount of time, and where it was spent, right? Whether it is the NQ or the block itself, whether it was sent directly or indirectly, all this across the 4 nodes you can see. We also have dynamic remastering statistics, which shows how much the DRM contributed to making sure that your workloads can scale better. We also have what we call as histograms. Now, histograms are really, really important to understand performance issues. This is something that I always recommend to look first. Now, in this case, I've used an Exadata. So in this case, Exadata specific workloads statistics are also reported if you're using Exadata. So in this case, you have information about the server health, the Exadata statistics, the server configuration, and all that. And here you can see that you have a particular wait event. Now, don't worry about the wait event itself, but what is very important is that you can see that we have broken down into different buckets the amount of time it took for each wait event. So you can see that most of the wait events are happening within the 256 millisecond. And in fact, if you look at it, it's even most of it is between the I would say 32 microseconds. So what is the importance of this? Well, when you run when you have a problem, when you're trying to find an outlier, what I call an outlier is, hey, there is this one thing that I do, or everything else runs perfectly, but there's this one thing when I do, it is showing some problems or slowing down. This is the way to find out that outlier, so that you can find out, oh, so why is this during this period of maybe during backup I'm seeing this? Then you know that how you can try to figure out and tune it. If 80 to 90 or 90% of your histograms are in the left side of this, then that means you're doing really, really good. Similarly, you have this small read histogram, in this case, the read from the flash to disk. You can see that thing is done for you in less than what we call as 256 microseconds. And there is some spillover which goes to disk, but this is very less number of times, and this happened like twice for this 112 milliseconds. Now, this is very important to understand because histograms make it easier for you to understand and figure out your outliers. Okay. This is actually a customer quote, and this is something that I think this is important to know. This customer basically said that, hey, if you have not looked into the new generation Oracle RAC 19C yet, you're not experienced what RAC can do for you. And there is a list of all the new generation Oracle RAC features that is in that URL. And as I keep saying, the slide share that I have has all these features that I talked about. And as I've always said, I'm always here to help you out. If you have a question, either you can DM me, direct message me on social media, or send me a message even on Q&A. With that, I want to tell you that Oracle RAC is the #1 proven choice for scalability and availability, not just for this small set of customers. These are just the customers I've been working with recently, but for a lot of customers. In fact, Oracle RAC, along with Exadata, touches pretty much every aspect of a typical life, including from your coffee to your transactions, to your investments, to when you swipe your card, to when you call people. So it's all covering every aspect of your life. Okay. With that, I want to thank you for attending this session on behalf of the Oracle RAC product development team. We are very, very happy to have you as customers. With this, I will pause and I will see if there's any question that I need to take live. There seems to be a lot of questions. Interesting.
Yes, Anil, indeed. There were two particular one. Maybe I can read them out to you.
Sure.
One is, I don't get the importance of colocation tags. Do they have benefits versus the use of services with preferred and available rack instance?
Yeah, perfect. Good question. So simply put, when you use services, so let's say you have a service called sales and you have a 3 node cluster and you're running the sales service is running on 2 nodes. Now, what would happen is when there is a session coming in, we have a choice to send it to node 1 and node 2. So if you have load balancing set up, if you send 100 connections, they'll all go to 50 will go to node 1, 50 will go to node 2, because even though you have 3 servers, you have defined that I have my services running on node 1 and 2. Now, let's say that this is actually doing the similar kind of work. What would happen is 1 and 2 no instances will have to send some blocks back and forth because work is going concurrently on these 2 services. So you could optimize it saying, hey, you know what? Out of my services, that is the work that is coming for your sales, the ones that are coming from EMEA, I want to put it to node 1, and ones that are coming from, say, North America, I want to put on node 2. Using colocation tag, you can further tune where your sessions end up than just using services. With services, you say go to 1 and 2 or 1 or 2. With colocation tag, you can give a hint saying, hey, maybe I should, this should go to 1 rather than 2. That's the difference.
Brilliant. And then there was another one. There was a particular slide. I need to revisit that slide. I thought I heard Anil mention something about resource monitor, which was specific to rack, tracking blocks in cache.
Yes. Yes, and I will try to say this in a nicer way. So what I call as monitor used to be referred to as master in the past. We are not using those terminology nowadays, but I know it. If I use the older terminology, it may be similar, but don't confuse resource monitor with the resource managers and other things. It used to be what we used to call as the resource mastership and all that. Now we are using the term called monitor to be compliant, and this is the right way to do it. So we are going to use it resource monitor. The resource monitor is nothing but what we used to call it in the past as resource master, which used to be the block which knows everything about the other blocks. Okay.
Right. Brilliant. Let me skim through the questions here. Let's see what are the recent ones that came in that were not answered yet. Thank you on the issue production go live.
So there's one, Kevin, on the very beginning we really missed. And is there any link to understand the fast index split optimization? This is going from Arturo. Is there any link to can drop or any places where you can refer him to, Anil?
I have talked about it a lot, but as I said, if there is anything that anybody wants to know a lot more detail, feel free to DM me. The idea is that we don't talk about these optimizations much in a written document or something. We talk about it in presentations. Is because we keep improving this in the back end, and there's nothing that the customer has to do to get benefit out of it. So the only thing the customer would do is saying, hey, let me run this workload on, say, 11 GR2, let me run this on 19, and say, oh, it's so much faster.
Okay, good, thank you.
Yeah. There is one question that I need to answer that it came in the start about comparing with what we call as, cold failover environments versus rack. It is very important to understand that rack is active-active. So whenever you think about cold failover environments, remember, cold failover environments take time to start and stop the instance, whereas with rack, we have active-actives that are already up and running. Sorry, I did not want to interrupt. Is there any other question?
So just one came in here. When is it useful to use scalable sequence, and what impact can it have on application code?
Yes, perfect question. So remember, sequences are monotonously increasing numbers. So what would happen is you would be able to cache some of this in the cache, which we already always had the mechanism to do so. If you have your application and your application uses sequences and you are okay with having gaps in the sequence, then you get the best of both in a RAC environment when using scalable sequences. Because say instance 1 will say, I got 5 to 9. Instance 2 would say, I got 13 to 21. Instance 3 would say, I got 40 to 66. Now, if your transaction goes into instance 3 and tries to get the sequence, even though the minimum number across the instances say 6, it may get 42. But we will make sure it's unique. But what we are not giving you is the ordering of sequences to be in the same way as the transactions come in. So basically, we are using the node or instance number as a way to spread out the sequence numbers, so we don't have to synchronize as much, which will help you improve your performance. You need to look at your application and business logic to say, oh, if you have an application that says, no, I have to make sure transaction X at time T has to be having a sequence number lower than a transaction Y at time Y. So if you have these requirements, which are really not something that the modern application development frameworks follow, but if you have it, you cannot use it. But if you don't, you can definitely use it.
Hey, Anil, there are a number of questions about performance, scalability, as you can imagine on the chat. Any suggestions for the people on the call to follow up on those questions? Should they get in touch with you through your blog, Oracle support? Can you provide some guidance here?
Definitely. Good question. So this is, I like good feedback. So I guess one of the action items for me is to have a dedicated performance tuning session in the future. I hope we are able to do one as part of the masterclass series eventually. That way, customers can benefit from understanding how does, say, Anil read an AWR report so that they can benefit from it. So that is something I can do. In the meantime, if it is a long time, in the future, and you have some immediate need, I keep saying, send me your, DM me your request or your question. I will try to answer it. I'll be honest, I try to get to at least 5 to 7 requests per day on social media. So within 24 hours, I will try to get back to you on some of these things.
Well, that sounds great. I saw there were a number of questions and suggestions. Let's do a class on AWR report. So let's put this into the pipeline for the masterclass series. That sounds definitely interesting. All right. I know we're already over time. Thanks a lot, Anil, for joining us in your early morning. Thanks a lot for the presentation. I think it was awesome. Thanks to everyone who joined. I think looking at the number of questions, looking at the number of attendees today, I think this is definitely something that we should look into more detail into these topics. I hope you enjoyed it. Other than that, have a great day, great evening. Stay safe and take care. Talk to you soon. Bye-bye.
Thank you.